Hi guys, now we're back with the really cool part of this lesson, which is how to lie with statistics. So let's just look there on page 10 and you'll see two graphs, and you'll notice that the vertical axis says sales in thousands for both of them and the year. And if you look at the one on the left, it looks like sales are increasing quite a bit year over year, where this one looks like maybe a very tiny increase. Well, the truth is, this is the same data. And the way that they've chosen the scale has actually influenced how we perceive it. So this is exaggerating, look at how well we're doing, and this is downplaying what we're doing. So I want to show you how to do both of these things, not so that you start lying with statistics, but so that you become a little more critical about the statistics we see in the media and know that people are often lying to you to influence you and the way they want you to see this information. So we talk about this in terms of bias. So I have a few notes for you. You guys just have to fill in the blanks here. So bias versus unbiased bar graphs. So graphs can be used to display data at a glance, and they can influence results. The graph may not be accurate or without bias or distortion. So bias is something influencing you, and distortion is basically the same thing, distorting the data to make you look at it a different way. So I like to call this How to Lie with Statistics, which is the name of a book as well, which is an interesting book. But again, I'm a nerd, so I find all this stuff interesting. So I want to go back to this graph for a minute and show you what the difference is, just briefly. If you look at the first one, the minimum value on the y-axis is 125 and the maximum is 160. Where on the one that's downplayed, the minimum value is 0 and the maximum is 160. So if I put this 125 on this graph, it would actually be about here. So this part of the graph is just zoomed in and stretched on this graph to exaggerate it. So imagine we could do that with our camera right now. I just zoom in here and stretch it out, and you'd think this is much, much taller than that. So that's essentially what they're doing. So I'm going to use those words zoom in and zoom out because I think it actually helps you understand what's going on. So if we want to downplay the differences, which is we're going to start with exaggerating. If we want to exaggerate, we want to zoom in the scale of the y-axis, or actually decrease it, right? We just want to take a little piece of this here and zoom in. So we want to decrease, and underneath this I'm going to put zoom in the scale of the y-axis. This makes the differences appear larger. So what you do is you begin the vertical axis at a value just below the smallest data value. So they saw that that was, around 135. So they went to 125 instead of all the way down to 0. So we're going to put the word below in here. And then we want to keep the maximum value close to the maximum value of the data. We don't want to have the maximum be way up here because that's just going to shrink this down. What we're trying to do is stretch this out, right? So we want to keep it as close to the top as possible. Now, if we want to do the opposite, if we want to decrease the differences, we're going to increase the scale, really zoom out on the y-axis to make those differences appear smaller. And you're going to do this by beginning the vertical axis at the smallest value you can, which is 0. And then you're going to, choose a blank value on the vertical axis that is much smaller than the maximum value of the data. Now, so this is choose a maximum value. So I had to think about that for a second. Choose a maximum value on the vertical axis that is much smaller than the maximum value of the data. Now, they didn't really do that here. They chose 160 on both of them. But I'm going to show you how to do that in our first example. Okay, so I took a few minutes to fill in a few things. Obviously, the name, the title, criminal code offenses, which I've underlined, the number of offenses on the y-axis or the vertical axis, and the year on the horizontal axis. Now that was pretty easy, right? Because I'm just going to use two squares and then a space, 2 squares and a space. But this is what took a little bit of figuring out. The first thing I realized is that I did not want to have to fit in these big numbers, 2,650,000, 2,500,000. So what I did is I put a decimal in this space here, basically by dividing each of these by 1,000,000. So instead of putting in the whole number, I could put in 2.65, 2.5, 2.45, etc. The other thing I really needed to work on is, well, how big should my scale be? So remember with these ones, we don't want to start at 0. We want to start just a little bit below what the minimum is. So my minimum was 2.3 million and my maximum was 2.65 million. Now, if I take those in my calculator and put 2,650,000 minus 2,300,000, what do I get? Well, that's a nice number, 350,000. Now from 2.3 to up to here, I knew I had 14 spaces, so I divide by 14 and I got 25,000. Now I like working in 25,000s because I see that all of these are kind of end in 50s or in zeros. So I started here and every tick was 25. So to go up 50, I'm going to have to go 2. To go up 100, I'm going to have to go up 4. So from 2.3, 2.4, 2.5, 2.6, and then I just filled in what's halfway between 60 and 50, 55. What's halfway between 2.4 and 2.5, 2.45. Again, guys, if you're comparing decimal numbers, you just add another 0. 2.40, 2.50, what's halfway? 2.45. So remember, I wanted to zoom in at just the top of this graph. So once you make yours look like mine, so just pause this whenever you're ready to take a minute to do that, then come back and we'll fill in the values. Okay, so hopefully you're back now, and let's take a look at what these values are. And remember, I'm just going to put in the bar at the top. So 2.65 million is right at the top. I'm going to do this from the bottom so that I can see what I'm doing. So there's 2.65. 2.5 is down here. Remember, I want to go there. 2.45 for 1998. 2.350 for 1999. And 2.3 for the year 2000. So you can see that really exaggerates the differences. So again, we'll press pause. I'll fill these in, shade them, and then you'll see the final product. Okay, so here's my finished product, which I think really does exaggerate the differences here. If I quickly looked at this, if it was part of an article, I'd say, wow, crime sure is decreasing over these years. Look at the difference between here and here. Of course, most people aren't going to go over here and go, oh, there's still 2.3 million criminal code offenses here. So this isn't so great. So your next task is to do the same thing, use the same data, but this time I want you to minimize the differences. So for example 4, what they want you to do is they want you to look at it as if you were a newspaper reporter. So again, I want you to start at 0 because we're trying to minimize this, and then go to the maximum. Sorry guys, I'm having a hard time getting this, and Podrig's running out the door right now. And then the year on the bottom again will stay the same. So I knew I had 15 spaces, so I chose number bigger, so 3 million from 0, and I knew then that this every million would be 5 ticks, and that's how I decided on this scale, and then this was the same. So why don't you take a minute to get that scale down. Again, every 5 ticks is a million, and notice I put millions here when I'm changing this to a decimal. So this is 2 million, 3 million, and then take a moment then to put that data in, and we'll compare what you get to what I get. Okay, so here's my finished bar graph that minimizes or downplays the differences. And you can see there's not much difference here, but you can see a decrease, that the y-axis starts at 0 and goes up to 3 million. Remember that trick about changing it into millions, so it's easier to write down the numbers. And I just want to spend one more minute talking about how this, in a way, is also misleading. And you may say, well, no, Miss Hope, because really it's showing that it hasn't gone down that much. But again, that's a matter of perspective, because that's still a drop in hundreds of thousands of criminal offenses. So then the question becomes, well, what's the best way to display this data? Well, it's not the people displaying the data who decide what's the best way. It's actually the person reading it. We need to be numerate. We need to be people who can critically examine these graphs and look for the sorts of things that we've learned about here to know when we're being misled or when we're being influenced to see the data the way the writer wants us to see the data. So again, this can also be misleading because, again, does it matter to you that it's dropped 100,000 people, 50,000 people, 20,000 people? Those are still big numbers. So I can tell you, having worked in statistics, that there are ways to measure whether these differences are statistically significant. But often when we're using statistics to lie, people don't care about that. They just want to show you graphs that make you believe what they're saying. So again, be critical about these things. Use the knowledge you've gained today about the changing of the scale to know they can really mislead you. And, maybe if you want to present your grades to your parents in a bar graph, you have a nice way of misleading them one way or the other. So it's not all bad. Anyways, thanks for letting me teach this way, you guys. I'm sure it's a little weird, but I thought it was a good solution given that I can't be there with you right now. So thanks, and I will be back with the next lesson in a day or two. Bye.